today's tutorial. Today we want to look at the vertebral column. You know the vertebral column, the name I will call it the backbone or the spine or the spinal column. I remember it's not the spinal cord because the spinal cord actually goes through a canal created, which we'll get to know. It is never, this is the spine or the spinal column, vertebral column. Now, this vertebral column, yes, of course, in males is around 71 centimeters long, in females around 61 centimeters long. Now, if you take an average man, let's say, whose height is around 175 centimeters long, approximately this will contribute about 40% of the height of the individual. Now, this bone is actually very flexible because opposed within it are some discs, known as intervertebral discs. They are in between the ribs, so in between the vertebrae, and therefore we call them intervertebral discs. Outer aspect is actually made of a fibro cartilage, and that called what we call annulus fibrosis, from the ring outside, annulus fibrosis, and then the inner portion is the nucleus pulposus. Now remember that if there is too much weight, especially around the lumbar region, then posterolaterally, then the annulus fibrosis can rupture for the nucleus pulposus to leak out, and that is what we mean by slip disc. Now, this intervertebral disc, apart from absorbing shock, so that the bones will not be in contact with each other so much, reducing friction, also makes this vertebral column actually flexible. Now it contributes about 1/4 of the length of the intervertebral disc. Now remember that during the day, as you move, what happens is that the bones compress on these intervertebral discs, reducing the length, so that in a day, what happens is that the length of an individual becomes shorter compared to immediately after waking up, so that the water and everything would have regained by the intervertebral disc. Now generally what happens is that, yes, they are divided into bones which are located in the neck region, known as the cervical vertebrae. Cervical has to do with the neck. Bones that are related to the chest region, posterior aspects, that's the thoracic region, thoracic vertebrae. Then those in the loin area, the lower back area, and that's the lumbar, vertebrae. Then of course we have the sacrum and then the coccyx. Actually we have about 33 bones, of which some are fused and then some are separate, which we'll get to know them pretty soon. Now, this bone, if you take a look at it from a lateral view, you get to know that it's actually curved, having some curvatures. These curvatures are actually very important, and there are two groups of these curvatures. We have the primary curvatures and we have the secondary curvatures. Now, the primary curvatures were actually developed in utero, inside your mother's womb, when you were a fetus, and it's actually the birthright of an individual. So you came with primary curvatures, and developmentally, from 3 months upwards, you develop the secondary curvatures as well. So the primary curvatures are these ones: the thoracic curvature and the sacral curvature. Now these curvatures, if we are taking an anterior view, then they will be concave anteriorly. So the primary curvatures are concave anteriorly, but they will be convex posteriorly. If we are taking a posterior view, then these primary curvatures will be convex anteriorly. And you said that usually, they will develop inside the fetus, within the fetus, and of course inside the mother's womb. Now, the other group that we get to know are these ones, which are located in the lumbar region, as well as in the cervical region, in the neck region, and they represent the secondary curvatures. Now, these secondary curvatures, usually develop from the neck region, where the newborn around 3 to 4 months begins to hold the head, raise the neck and what have you, raise the head, that's when the cervical secondary curvature begins to develop. Now, for the lumbar secondary curvature, that's when the individual learns to sit, stand, and what have you, usually up around the 9th month, upwards. So these are the curvatures that we have to understand. Now, some of these curvatures could be exaggerated and may result in pathology. For instance, if the thoracic curvature becomes excessively curved, so that it's, if we are taking a posterior view, it becomes more convex, or if we are taking an anterior view, it becomes more concave. And this results in what we call kyphosis, hunchback, exaggerated curvature of the thoracic vertebrae. Now, on the other hand, we also have, exaggerated curvature of the lumbar vertebrae, and that is when, it becomes more concave posteriorly or more convex anteriorly. And that is what we call lordosis. And this lordosis, yes, sometimes it could be physiological, especially in pregnant women. Then of course, those individuals with large belly, pot belly individuals who also have this lordosis. Now the layman will call, of course, the kyphosis hunchback, the lordosis sway back. Now sometimes to this vertebral column, especially around the thoracolumbar region, who assume an S-shaped, it will curve laterally, exaggerated curvature, laterally. Then that results in what we call scoliosis. Now, this scoliosis, usually we call it twisted disease, is of medical emergency because sometimes it can hinder, even respiratory mechanisms. And so these are the general, as well as the curvatures that we have to know. Now, if you take the bones that form the cervical vertebrae, they are 7 in number, and usually we use the word, we simply refer to them as C1 to C7, cervical vertebrae around the neck region. Now, these bones, before let's look at a general trend again. Now, generally what happens is that there is a foramen or there is a canal within them. And this canal, as you descend, what happens is that the canal narrows. Why? Because the body of the vertebrae, which we are going to learn, will be increasing in diameter or in size, and therefore taking up some of the space that we find. So what happens is that generally the body will be increasing as we move inferiorly, but what happens is that the canal will also be decreasing as we move inferiorly. So we want to look at generally what is the structure of this vertebrae that we are talking about. The bones that make up this column, this backbone, is known as the vertebral column. Now, using this to illustrate, generally every vertebra will present with the body. This is the body, and it will also present with an arch. So this is the body, the weight-bearing portion of the vertebra, and an arch. Now the arch actually encircles, so that we get this foramen, which is known as vertebral foramen. Now, the arch also has the following. In addition to the part, it has posteriorly this spine known as spinous process. It has on it transverse aspects, known as transverse processes, will be there. It will have what you call superior facets, 2 superior facets, and 2 inferior facets. Generally, this will be the vertebral, components that we have. Of course, there will be some notches, there will be an inferior notch, there will also be what superior notch of the vertebra. So that, of course, when assuming these are 2 vertebrae which are opposed to each other, then they will create what we call intervertebral foramen. In between them, there will be intervertebral foramen, which you have to know. Intervertebral foramen. Now, So these are the general things that we have to understand. But for each region, when you look at the neck, the vertebrae over there have peculiar features. The thoracic region, they will have their peculiar lumbar, and as well as even. So usually examiners would like to ask questions in that regard. So let's look at the cervical vertebrae. Now, although these are atypical vertebrae, I'm just going to use them to explain what I mean by cervical vertebrae. Now, cervical vertebrae, yes, we said they are in the neck. What happens is that they have a very small body. Their body, which is the vertebral body, in this case, this one is very small. Therefore, they will have a larger vertebral foramen, or spinal foramen. Now, this vertebral foramen is triangular shaped. Now, again, what happens is that, yes, apart from the other features we know, their spinal process actually ends in two tubercles. Therefore, we said it has a bifid or Y-shaped spinal process. Yes, in addition, in the transverse processes, there are some openings in there known as foramen transversarum or transverse foramina on either side, and it's peculiar characteristic to cervical vertebrae. So these are generally the features that we are going to help you in distinguishing between cervical vertebrae and any other vertebrae. Now, cervical vertebrae 1, 2, and 7 are described as atypical. Now, 7 is known as vertebral prominence, yes, because it's used in counting ribs, so it's quite prominent. This cervical vertebra 1, 2, 3, 4, 5, 6, and 7. Now, this 7th one is quite prominent in the neck region. Therefore, once you can identify, palpate this one, and it can help you in counting of these vertebrae. So we call it vertebral prominence. Now, for cervical C1 and C2, they are given special names. C1 is known as atlas, and then C2 is known as axis. Now, let's show these ones. Now, this is the atlas. Now, the atlas, remember T comes before X, therefore C1 is atlas, and then C2 is axis. Now, this atlas doesn't have a body, does not have a vertebral body, neither does it have a spinal process. But what happens is that it has tubercles. It has an anterior tubercle and a posterior tubercle representing it. These will be the tubercles. And then, of course, it will have an anterior arch and a posterior arch. And then it will have these lateral aspects, which we call them lateral masses. So generally, it's lacking a spinal process. It's lacking a body. They are the identifying features. Now, if you look at this area, this superior aspect of the bone, it's actually for articulation with the occipital condyle of the cranium, which we'll look at later. Occipital condyle. So these are facets for occipital condyle. They are concave in nature, slightly concave in nature. Now, its vertebral foramen is unusually large. In fact, it's unusual. We said that cervical vertebrae will actually have triangular shaped vertebral foramen, but for this one, it's unusually large. And the reason is that it actually has to provide anteriorly accommodation to this C1 process that we find here, which is tooth-like, known as dens or odontal process of the axis. And so it has to provide, this kind of accommodation so that it can actually run through it this way. And so it's unusually large. Yes, apart from this, but essentially that's what we are going to see for the C1 vertebra, atlas. Now, for axis, the unique feature about it, apart from having the other features, is that it's going to have this tooth-like process known as odontoid process. Actually, this is believed to be the body of the atlas. So this is the cervical vertebrae that we've looked at. Now, the next one that we're going to talk about is the thoracic vertebra. But of course, remember that the cervical vertebrae although it will have, bifid, spinal process, it's going to be shorter relatively. This is the thoracic vertebra. And if you take the thoracic vertebra, the unique features over there will be that its body, its heart is heart-shaped. It has a heart-shaped, body. Its foramen is oval or rounded in nature. Vertebral foramen is rounded. Yes, of course, it's going to have a spinal process which actually orients inferiorly, which actually orients caudally. Okay, long inferior pointing spinal processes will be present. But in addition, what happens is that on the body, both superiorly and inferiorly, not very clear, superiorly and then of course inferiorly, on either side of the body, you are going to have what we call facets, okay, which they are not full facets, so we call them demi-facets, okay, for articulating with the articular facet that we find on the head of the rib. So these are the facets that we find. In addition, we are also going to find facets on the transverse process. These ones are actually full facets. They are costal facets, which you find them, okay, for articulating with the articular parts of the tubercle of the rib. So these are the costal facets that we have. Now, just to add this to it, in fact, this foramen that we have, actually generally for most vertebrae, will actually be formed by what we call anteriorly. These are the pedicles, this arch. So these are pedicles. Okay, anteriorly you have these pedicles, and on these sides where you have the spinal process emerging, posteriorly we have the laminae. Singular is lamina. So these are the things. Now, we said that yes, these vertebrae, are going to have these features, but we have some vertebrae, although they are thoracic vertebrae, they are atypical. And notably, you are going to have thoracic vertebra 1, thoracic, vertebra 2. We're also going to have, thoracic vertebra 9, 10, and of course 11. For thoracic vertebra 1, what makes it atypical is that it has a complete facet, yes, for articulating with only rib 1, complete facet. For thoracic vertebra 2, instead of having, yes, superior and inferior, articular facet, costal facet, or demi-facet, it's not having the inferior one. It has actually just the superior one. For rib, for vertebrae, 10 to 12, what happens is that they have only articular facets, for the superior, at the superior aspect. They don't have that of the inferior. Yes, it's demi. Yeah, that's all right. So these things actually make them atypical. And for rib 1 again, instead of having an inferior pointing spinal process, it's actually not inferior pointing anyway. That's what we tend to find. Now, for the lumbar vertebra is having a kidney-shaped or bean-shaped vertebral body. It's having a triangular-shaped, vertebral foramen. But what happens is that this triangular shape, of course, is going to be smaller compared to that we find in the cervical vertebrae. And then it's going to have a stout, somewhat rectangular shaped transverse process, which doesn't, move inferiorly. So usually it doesn't cross below the level of the body. And yes, it doesn't have costal facets. It doesn't have, these demi-facets we've seen, foramen transversarum. And so these are able to help you in distinguishing between, the thoracic vertebrae from cervical and then from lumbar. So they are very important as distinguishing features. Now, remember that there are 7 cervical vertebrae, but 12 thoracic vertebrae. 5 lumbar vertebrae, they are all fused. And then of course we come here, which is the sacrum. The sacrum is actually consisting of 5 fused sacral vertebrae. 5 fused sacral vertebrae. Now, these sacral vertebrae, because they are fused, will therefore have the spinal processes also getting fused, so that at the end of the day we have this median sacral crest. And then of course, on the lateral aspects, which represent the transverse processes, will be the lateral sacral crest on either side, lateral sacral crest. Then of course, at this posterior aspect, we are going to have 4 on either side, these openings, known as posterior sacral foramina. And then of course, anteriorly, we are going to also have these ones as well. Now remember that it's triangular shaped. It's actually its apex orient inferior with its base being superiorly placed. And yes, it is going to have its canal inside. Now what happens is that these vertebral foramina are going to fuse together to form a single vertebral canal, so that the spinal cord will actually go through it together with its meninges and of course associated structures. So that is what we find. It will still have its canal. Now at this side we can have sacral hiatus, and these are the horns which are known as sacral conua, for this sacral hiatus. Now the inferior bone, which actually consists of 4 bones, it doesn't have a canal inside, is known as the coccyx, consisting of 4 fused coccygeal vertebrae. There's no space within it. These ones will represent the transverse processes. It's also triangular shape with its apex orienting inferiorly. So these are bones of the vertebrae, but stressing this. Now the reason why sometimes you want to take some sample from this area, from around the spinal cord, then what happens is that usually if you go through the lumbar aspect, it is very good. And because the thoracic one, you can see how the vertebrae, the spinal processes orient inferior, even conferring more protection to the spinal cord than these thoracic, because you can see these spaces. But these ones are actually slanting inferior to confer even more protection. Ladies and gentlemen, actually, yes, this this bone is actually having a wing, which is the sacrum, having a wing for articulating with the ilium, so that we can have sacroiliac joints happening here, and forming part actually of the bony pelvis. Ladies and gentlemen, this is a quick tutorial on the vertebral column. Thank you.